the other part of lesson 5.1 is solving equations. Okay, so we are solving equations that have trig functions in them. Now, various equations, some of these are going to relate back to some of our algebra skills. We're going to be able to use, some of those. Just kind of depends. But we're going to start very basic, okay? And look at the equation, sine x equals 1/2. Now, all of the equations that we are doing, we are going to solve over the interval 0 to 2 pi. And I realized after the fact I should have typed this as a parenthesis. So it's 0, everything up to 2 pi. And if you think, what is 0 to 2 pi? That is once around the unit circle, yes? So we are looking for all answers on one trip around the unit circle that would make an equation true. Okay? Now, with number 1, sine of x equals 1/2. Okay? There's no manipulating this equation to do like there are for some. We have it, a trig function equals 1/2. So basically we want to know x. We can think of it as sine of what angle equals 1/2. And this is where your unit circle / trig chart come in handy.
30.
Okay, so what I've heard is pi over 6 and 30. Now, what do we know about pi over 6 and 30?
Same.
They're the same thing, yes? One's radians, one is degrees. I will tell you our answers are going to be given in radians today. Okay, so sorry to veto, but we are doing radians. Okay, so yes, that is true, because if we do sine of pi over 6 equals 1/2. And the chart tells us, yes? If you look in the sine column, there's a 1/2 in the 30 degrees / pi over 6 row, yes? Now, that's one answer. There's more than one answer on a lot of these problems. It's going to be more on the unusual side, only have one answer. That answer is in quadrant 1. We need any possible answers that apply as you make one complete loop around the unit circle.
Would the next one be
What'd you say?
not pi over 3?
No.
That's in the. Well, it would be 11 pi over 6.
No.
Negative 11. 7 pi over 6.
No.
Pi over 3.
No. Okay. So first of all, we're talking about when sine equals 1/2, yes?
Yes.
There is no place else in quadrant 1 where sine is going to equal 1/2. Now, let's go back and use the thought of all students take calculus. Okay, we are looking for places where sine equals 1/2. 1/2 is a positive value, yes? So we already have a first quadrant answer. Where else is sine positive?
The second.
In quadrant 2. Will I have answers down in quadrant 3 or 4?
No.
No, because sine isn't positive there. Now, here's the deal, guys. What'd you say the first quadrant answer was? You said pi over 6, yes? We're looking for the answer in the then other positive sine quadrant, which is second. That is the equivalent angle. And when I say equivalent angle, it has the same distance from the x-axis. We're talking reference angles here. So it has the same distance from the x-axis. And what's that other angle? 5 pi over 6. Okay. So my solutions here are pi over 6 and 5 5 pi over 6. Okay? That's the idea of your last step every time is going to be, you know, a trig function equal to a number. Where does it equal that number? You could have, technically you could have no answers. We'll experience that at some point. We could have 1 answer, 2 answers, 3 answers. You could have 4 answers. Okay? It all depends on the situation. Okay? Also, if you're looking on your unit circle, do remember, and I prefer the way we just talked about this, but as a side check, what is an ordered pair? The order in an ordered pair is cosine sine, yes? So as you look at this, you're looking for, okay, where is my y value? 1/2. And my y value happens to be 1/2 at pi over 6 and 5 pi over 6. Okay. One way or another, are you with me? Okay. Okay, let's try 2. We have to tweak it a little bit. We have cosine x plus 1 equals 0. Okay, so normally when you're solving an equation, your job is to get x by itself, right? Well, it's kind of getting x by itself. It's getting the trig function by itself. So in that case, since this is cosine x plus 1, I'm going to think minus 1. So now my equation becomes cosine of x equals negative 1.
I agree. No, it's wait. I agree with that. I agree with that.
Now, I saw some confused looks at first. What's the first issue you run into? If you go to look on the chart, on your trig reference chart, does cosine ever equal 1? No, cosine never equals 1 at our 3 normal reference angles, pi over 6, pi over 4, pi over 3. But if you think about it, when do zeros and ones and negative ones often occur? They occur at our quadrantal angles, yes? So now we're thinking about our quadrantal angles. And we just reviewed that an ordered pair is cosine sine, yes? So we're looking for which quadrantal angle is my x value, negative 1. And where does that happen? Over here, yes? This is the ordered pair, negative 1, 0. And this is the angle pi. It's hard to write work for these. Like, I can verbally explain, but it's not like there's work to write. So the best I can do is just kind of give you a, an image here to look at. Okay, so you guys said cosine equals negative 1 at pi. Any place else? We'd have 1, 0. We'd have 0, 1, 0, negative 1. Does it ever equal negative 1? No. Now, we can say pi. Technically, if we go around the unit circle again, we could say 3 pi. We could say 5 pi, 7 pi, so on and so forth. But this is why I'm only asking you to give answers on the interval 0 to 2 pi, because otherwise there's an unlimited answer. Now, I feel like it's maybe this homework, I'm trying to remember, where the directions on one of the sections, the answers they might give you might be something like pi plus 2 pi in, meaning like that's kind of a, for however many times you want to go around the unit circle, that you could give answers, okay? We're just giving our basic answers here, okay? So, on this particular problem, it's kind of unusual today, but there's only one answer. Okay? So, My side note to myself is that as we're doing this, we are going to check the unit circle. I'm going to say slash trig reference chart for values. That's going to be the name of the game today.
Will we go back to like what we were doing last unit with like the identities?
We are going to use identities some, yes. Okay. Identities are not gone, don't worry. And in 5.3, we start adding more identities to our list too.
More?
So. Okay. Ready to talk about 3?
Yes.
Okay. So, you guys know how math works. We start off with the basic example, right?
Yeah.
Each time we kind of notch it up a little bit. So, first example, just how you process sine x equals 1/2. Second example, okay, we had to get cosine x by itself. Third example, cosine squared x plus cosine x minus 2. Actually, I'm going to put on another screen so I have room. Do you see anything?
Yes. Subtract over a cosine x and a 1 so that you can read a cosine squared x minus 1 and use the Pythagorean identity.
While yes, it would be true, I don't think it would help us solve the equation.
Okay.
It's actually, as we solve equations, it's actually better if you have all the same trig function. Okay, so the fact that this is all cosines is for the better. Okay, save your Pythagorean identity ideas for when we don't have all the same trig function. Okay.
So we factor out cosine?
If there were only cosines, I would go with factoring out GCF. But there's also that minus 2 term that doesn't have a cosine.
So it's not with the cosine? So do you...
No, this is 3 terms. This is cosine squared x plus cosine x
so you add the 2
minus 2.
And then you can factor?
Again, you can move that 2 over and you can factor out GCF, but we don't have a place to go with it. Okay? Now, okay, think factoring though. And I'm going to take us back to the basics here. I want you to think about this as x squared plus x minus 2 equals 0. So basically, if you just drop out the cosines for a moment, can we do that?
Yes.
Okay, they're not gone. We have to put them back in to get answers. But this is kind of my introduction. How do I get you guys to see this? So drop off the cosines for a moment. If this equation was x squared plus x minus 2 equals 0, how would you solve that?
X minus 1. X minus 1.
I disagree with her numbers, but we're going to factor into 2 parentheses,
Oh,
yes?
Minus 2.
X squared becomes x and x. Numbers that multiply to be negative 2 and add to be 1. Or what? Positive 2 minus 1? Okay. That's what your brain needs to think. But now we've got to put the cosines back in. So the idea here is I see a quadratic. I see cosine squared, I see a cosine, and I see a constant. So I'm going to think in terms of 2 parentheses. Now, when I asked you x, how do we break x up? You say x times x. So how do we break cosine squared up? Okay, so we're going to break this up as cosine x times cosine x. We still need values that multiply to be negative 2 and add to be 1. And those numbers are still +2 and -1. Okay, so we're doing algebra here, right?
Yeah.
Doing the algebra that you're well schooled on, you're pros on. Okay. If this was algebra, what would be my next step? Solve them by setting each parenthesis equal to 0, right? Set each factor equal to 0. So I'm going to say cosine x plus 2 equals 0 and cosine x minus 1 equals 0. And then what do we do?
So,
Okay, solve, get the cosine by itself. So on the first one, I'm going to have cosine x equals -2. On the second one, we're going to have cosine x equals 1. And now are we doing the same type thing we did on 1 and 2? Okay. So your job is always to get to that place. It's just how do we get to that place? Okay, cosine x equals -2.
oh, is there none? Is there none?
Is there none? Why would you say that?
I can't find it.
You can't find it. You can't find it on the unit circle. You can't find it on the chart. Okay. On the chart, it's definitely not any of our basic 3, right? Pi over 6, pi over 4, pi over 3. On the unit circle, the only other ones we really add are 0s and 1s. And, so we add our quadrantals. It's not there. Here's what I want you to think with me. You guys know what the cosine graph looks like, yes? Basic here. Cosine graph does this over and over and over, yes? What do you know about that cosine graph? It goes as high as 1 and as low as -1. Will a regular plain old non-stretched cosine ever go down to -2? No, not unless it's either stretched or shifted. So this one right here just doesn't happen. It is not possible. Okay? Cosine just can't equal -2. Now, does that mean I'm done with the problem? No solution?
No.
No, because we have the other half we can look at. Okay, so now we're going to go through and think about cosine x equals 1. I don't want a 2 pi answer today.
0.
I can handle 0. Okay, and how did you guys do that? When does cosine equal 1? And that is happening at 0 degrees or 0 radians. And it's not that 2 pi is false. 2 pi is true. But when you give answers today, I want it from 0 up to 2 pi, but not including 2 pi. Okay? Because 0 and 2 pi are the same thing. We're going to use 0. So my solution here is x equals 0. As in 0 degrees or 0 radians. Okay? Okay, you ready to try the next one? Okay. Number 4. 2 sine squared x plus sine x minus 1 equals 0.
You have to
Okay. We have a sine squared term, a sine term, and a constant term, yes? So are we in that quadratic form? We are. Now, Kate mentioned product of AC. I wasn't actually going to have us do product of AC, but yes, technically it is product of AC. So again, you may or may not need it this time, but I'm going to have us think. Let's drop the signs out for a moment. If we drop the signs out, what is this looking like? 2x squared plus x minus 1 equals 0. Yes? Now, I agree. It is product of AC, yes? Or slip and slide. Now, my calc kids hate when I do this too, but I'm still going to do it. You can also think more of a basic guess and check. And this is a very easy one to do that with. So follow along with me. We're aiming for 2 parentheses, yes? 2x squared. What are my options for 2x squared? 1 times 2, right? 2 times 1. So 2x squared will break into 2x times 1x. I have no other options, do I? Now, look at your C value. 1. What must 1 break into? 1 times 1. Okay, so 2x squared gives me the front of each parenthesis. 1 gives me the back of each parenthesis. Now, how do we get the middle term? Well, that comes from your outsides and your insides. Meaning, it's just a matter of how we position the signs. If we need this to be a positive 1x, well, we have 2x times 1 on the outside, so a 2x. My insides are 1 times x, so that's 1x. How do we get them to add to be a 1x? Okay. Well, we need the 2x term to be positive. So it's going to be 2x times this 1. So it's actually going to be a positive here, and then a minus here. Now, if you are hating me right now for that, what is your backup plan? Product of AC. Or slip and slide. We looked at that a little bit, didn't we? I don't know if you guys cared for it, but... Okay, so product of AC is still good. I'm just trying to stretch your brains a little bit, okay? Now, we're not really working with x's, though. We're working with sine x's. So let's rewrite this. Instead of 2x minus 1, I would write it as 2 sine x minus 1. Instead of x plus 1, we would write it as sine x plus 1. Okay. What is our next step then? We have it factored.
Set it equal to 0.
Okay, set each factor equal to 0. So 2 sine x minus 1 equals 0. And sine x plus 1 equals 0. What about 2 sine x minus 1? What do?
Add the 1, divide by 2.
Okay, add 1. So 2 sine x equals 1. Divide by 2. Sine x equals 1/2. The other option, if it's sine x plus 1, subtract 1, and we're looking at sine x equals negative 1. Okay. So, sine x equals 1/2. I would start basic. When does sine equal 1/2? 5/6, yes? Does sine equal 1/2 any other time? Okay. And why 5 pi over 6?
Because it can be positive in the other quadrant.
Yeah. And we could say, oh, because that's what we already answered on number 1. However, you know, I want you rethinking that, okay, where is sign positive? First quadrant and second quadrant, right? So pi over 6 is the first quadrant where sine is equal to 1/2. The other angle is going to be the 5 pi over 6. Any other answers for sine for 1/2? Sine of x equal 1/2. No, we got the 2 quadrants. What about sine x equals -1? Sine x equals -1. We're no longer on the chart. Now we're on our quadrantals, yes? Remember the ordered pair? We're looking for when the y value is -1, because it's cosine sine. And that is happening at 270 or 3 pi over 2. Is there any place else my y value is -1? No. So, how many answers did I end up with? 3. We're growing. I'm trying to show you all the different answers you could have. Okay. Questions there? Okay. Ready to look at 5? 5, 3 tangent squared x minus secant squared x minus 5 equals 0. What's different? Yeah. It's not all sines or all cosines. It's not all of the same thing like it was last time. Okay? In order to really make this solvable, it needs to be all of the same thing. We have a tangent squared and a secant squared. We hinted at this earlier. We need to change one of those out.
What should we do for tangent?
No, because we still wouldn't have all the same. And I'm looking to have all the same.
Do you do
I would do a Pythagorean identity. Okay, so we have a Pythagorean identity that connects tangent squared and secant squared, yes? Okay, so what you're going to want to look at here is making this equation either all secant squared or all tangent squared. Now, me personally, when I go to my chart is sine, cosine, tangent. Because in my brain, I don't keep the other half of the chart. I don't keep secant, cosecant, and cotangent in my brain. Okay, I just keep those and then flip them when I need them. So with that in mind, I would suggest we go tangent. Now, what does secant replace with then? Or secant squared, that is? Secant squared is equal to 1 plus tangent squared. Okay. So we're using a Pythagorean identity there. Now, I recopied it. 3 tangent squared. Since it's minus secant squared, I put in parentheses the rest of my Pythagorean identity. Okay? Now, let's do some cleanup. I put the parentheses there just because there's a minus sign, yes? So if I remove my parentheses, I have 3 tangent squared x minus 1 minus tangent squared x minus 5 equals 0. Okay, what can I clean up?
You can subtract your 3 tan squared x and your
Okay. We've got two sets of like terms here, yes? 3 tangent squared x goes with minus 1 tangent squared x. What's 3 tangent squared x minus 1 tangent squared x? That is 2 tangent squared x. And then we have some constants. Minus 1 minus 5 is going to be minus 6 equals 0. So now I have 2 tangent squared x minus 6 equals 0. Okay, add the 6 divided by 2. This is just like solving the equation. That's the equation you're solving, yes? 2x squared minus 6 equals 0. So we're going to add 6. Two tangent squared x equals 6. We're going to divide by 2. So tangent squared x equals 3. And it's tangent squared, folks. In order to get tangent squared to become tangent, you want to square root. If we square root one side, we're going to square root the other side. The square root of tangent squared x is tangent x. What's the square root of 3? Square root of 3 and negative square root of 3. Plus or minus square root of 3. Does that make a difference? It does, because you just lost half your answers if you forget to put plus or minus. Okay? So, same old rule. There's your reminder. You're taking the square root in the equation setting, throw on a plus or minus. Now, you realize you basically have two equations you're looking at here, yes? You're basically looking at when does tan x equal positive square root of 3 and when does tan x equal negative square root of 3, yes? So, I go to the chart first. When does tan x equal square root of 3? 60 degrees pi over 3, yes?
Yes.
So I know one answer here is pi over 3. Now, here's my side note. All students take calculus. I have quadrant 1 done, yes?
Yep.
That is pi over 3. Where else is tangent x going to equal a positive square root of 3? What other quadrant do I need to look in? We need to look in quadrant 3. Okay. We need to look in quadrant 3. And so quadrant 3, you're looking for the equivalent angle that is the same distance from the x-axis. What is my equivalent angle that's the same distance from the x-axis? This one's just below the x-axis instead of above. 4 pi over 3. Here's a hint. It's the pi over 3 angle. Okay? I mean, there is a connection there. Okay? So my other one is 4 pi over 3. That's what's down here. Any other answers for tangent equals positive square root of 3? No. Now what do we need to do? Negative square root of 3. Where negative square root of 3 is going to be? That's going to be in my other two quadrants, yes? Because when is tangent negative? In quadrant 2 and in quadrant 4. So now, if I go quadrant 2 right here, what is the equivalent angle that is up pi over 3 from the x-axis? And that is 2 pi over 3, right? This is why I said have your unit circles out, yes? Because this is where the unit circle is helpful. So that is 2 pi over 3. And you know where this is going now, yes? We need the equivalent angle down here. One tangent is going to be negative square root of 3. And that is 5 pi over 3. Okay. How many answers? 4.
So if it's plus or minus, we basically just need data from every quadrant.
Pretty much, yep. I didn't want to come out and say that because I wanted us to process through it. But yeah, if you have plus or minus and it's, a traditional one of our basic 3, then there's going to be something from every quadrant. Yep. Okay.
Okay.
Six is not happening today.
It's okay, it's a fine day.
Yeah, no way, no how. Because each problem's getting a little bit bigger, isn't it?
Yeah.
Okay. So now, as you glance at 6 and your brains are in the mindset, any guesses on where we want to go?
Probably the
Tangent. Wait, no.
that one.
Yeah. What could we change cotangent to?
Cosine over sine.
Yeah, earlier I didn't want the quotient identity because I had 2 squared, so I wanted to go Pythagorean identity. Here, I've got cosine, sines, and cotangents. So we will at least start by going towards sines and cosines and seeing what we can make happen from there. Okay? But we will start that Monday.